today are primarily around these topics: machine learning, use cases of machine learning, why machine learning, what is the advantage we have, and obviously there is a huge uh, planning behind that. People are talking about machine learning, different types of use cases across industries. Yeah. So, and that brings us to the next question: that what is data analytics, data science, machine learning, artificial intelligence? They all are generally talked in the same breath. So we'll explore a bit on that. What technical stack you should know, yeah. What algorithms you should know, what algorithms are important. Slightly from the interview point of view also, because I understand that few of the participants will be interested more in the what is asked in the interviews, and few of you will be interested. How can we start on that? How can we start on the machine learning journey? So we'll explore on that also. Then we'll move to market basket analysis and recommendation systems, which will be finally completed using Python implementation. Now, all the slide deck, the Python code, the data sets, the results, they have been uploaded onto my GitHub link. I'll share the GitHub link towards the end of session. Yeah, please make sure you follow that and you execute that code yourself, please. Yeah. Okay, so we all know that data is a new oil, new electricity, whatever you want to call it, and this term has been used is in use for I think for more than 5 to 6 years right now. Yeah, where it has gained so much of traction, so much of popularity. Data can be divided primarily into two parts: structured and unstructured part. Structured part is mostly that part which is more into a row column like architecture, where uh, where let's say for example okay, let me 1 second, let me show that to you. So let's say, yeah, you have a customer ID, you have revenue. Yeah, so let's say you are the customer, 1 2 3 4. Yeah, and there is a revenue for you, so whatever, $100, $200. So this is more of a structured data set, okay, which can be represented in a row column architecture. Then comes the unstructured data set. Unstructured means which is not possible, where it is not possible to see in a row column architecture straight away. Like for example, text, audios, videos, pictures, you cannot represent them directly in their basic form. But that being said, you still need to convert them into numbers, right? Because your processors, your algorithms, they can process only mathematical numbers, and because of that we do convert them. Like for example, an image is made up of pixels, right? Pixels will have RGB values, red, blue, green values, 0 to 255. So you can convert those numbers, those text and images and audios and videos into numbers. That is unstructured data set. The second portion is that the data quality that rules the analysis. In the real world, you would find that data is really unclean, dirty, missing values, outliers, duplicates, junk values. All of that, they are a part of your data. Yeah. Now, what is data science, machine learning, artificial intelligence? How they're different? Now, let's put a definition to machine learning first. Machine learning, in simplistic terms, is we are showing the algorithm the historical trends, and based on that the algorithm learns those trends and predicts for the future. Like for example, if you have to teach a child that how can you open a doorknob, so what will you do? You will show the child that, okay, you take your hand, you hold the knob, you move it down or turn it right, and then push or pull, right? And then you can show the child that it is done like this. The child will have a look at that 10 times, 20 times, 100 times, and then will try to do it, himself. And over there the child will learn the process. Okay, same thing is happening in machine learning, and over here it is precisely different from software engineering. So in software engineering, your your rules are set. Like if this happens, do this. If this happens, do this. If the user presses on this particular tab, show that window. You write those rules before the software, during the software development process. Over here in machine learning, you do not write the rules. You show examples, and based on that, the algorithm trains itself. That is the meaning of machine learning, right? When it comes to deep learning or artificial intelligence, it is loosely used for your for AI related work, which is again automation of solutions. So AI is nothing new. AI has been in the trends, has been used for a long time. But when it comes to deep learning, particularly neural networks are again not very new, but in the recent 5 to 6 years, we have seen a lot of traction on the neural network side of things because of advent of Keras, TensorFlow, PyTorch, and all of that, right? And they have given the push to neural networks, wherein anyone you have Google Colab, so you can create your own neural networks and execute over there on the GPU. Okay, so that is the paradigm of your AI, your machine learning, and deep learning. Where does it data science sits in all of that? Now data science is an amalgamation, is like the juxtaposition of all of them, a bit of maths, a bit of stats, a bit of coding, a bit of business, a bit of deep learning, machine learning, stats, all of those things, they come into together, and they create a data scientist. Okay, that means you should know a bit of everything. I won't say master of everything. If possible, yes, please. Why not? But a bit of everything. Yeah. Um, that allows you to talk to the business, understand the business problems, devise a solution for that. Remember, I said devise or design. I'm not said create, because the first step is always designing and defining process. So this is intuitive for you, that if you're appearing for interviews, for data science interviews, machine learning interviews, please do not jump to algorithms, because when I take interviews, I see that okay, this is a particular case study. So how will you solve? If this is my question to the participant, so the answer I receive is that we will apply regression on that. That is maybe fourth or fifth step. Before that, you take cognizance of the data set, you design a solution around that. Yeah. So designing a solution is very important when it comes to the data science bit or machine learning bit of things. Okay. Um, that being said, this is the typical journey of a data science project. I won't spend a lot of time on that. I know we are limited on time, and I want to spend more time on recommendation models, on market basket analysis, on technical things. But these slides are uploaded to GitHub. The gist of the slide is that 70% of the time it goes to your data discovery, data preparation phase. Your machine learning algorithms, they contribute a small part of that. Yeah. Because till that point of time in real world, you are discovering that which tables, which databases I have to use and merge. Okay, all of them are dirty, so let's clean them. Let's calibrate the data sets, and finally, once I reach the stage where I can use it for my machine learning models, that time taken is really less. And you would see in the course also, in future sessions also, you will see that once we create our supervised learning models in the next session on regression, decision trees, random forest, all of that, you would see that the actual machine learning code is only few lines, right? Reaching that stage is a journey in itself. Yeah. Okay. So that you will see in detail in future sessions. But long story short, 70% of the time it goes to your data discovery and your data preparation phase in this phase itself. Yeah. Important one for you, that what types of skill we are talking about. This technical stack given over here is not exhaustive, but it covers most of the technologies available. I'm not requesting, I'm not suggesting that you should be a master of all of them. Instead, what I'm saying is that at least pick and choose at least one. Yeah. Let's say in data engineering, pick Spark, let's say. Yeah. SQL is required. SQL is one of the SQL is omnipresent, you can say that. Yeah. So you can pick and choose, let's say SQL you would have to have, right? Maybe pick Spark, let's say, right? For data analysis, Excel and SQL you cannot live with them without them. Yeah. Maybe between R and Python, you can choose one. Yeah. Machine learning tools, SAS or likes of MATLAB, SPSS, they are licensed softwares. R, Python, Weka, they are more open source ones. Okay. Visualization, pick one, right? They all are kind of similar products, similar services, similar offerings, right? But at least pick one, and then maybe pick one out of them, right? So what I'm suggesting is that at least get some experience. So let's say Tableau. I'm not suggesting that you should be a master of Python and be a master of Tableau. If that is possible, that's good. But if not, at least have some understanding that how Tableau works, how Tableau interacts with Python, how Tableau interacts with SQL, with CSV files and all of that, right? So that allows you to have a all-rounder personality, right? And particularly in the tough competition that you work with, it will be easy to get calls, interview calls, if you have some representation over everything, right? Okay, this is the technology stack. Good to know. Okay, now let's move to the next one. One second. Yeah, pointer. Okay. Here we talk about the types of machine learning algorithms we deal with. We have our supervised learning, unsupervised learning, semi-supervised learning. Supervised learning algorithms, what it means is that you do have a, a target over here, a target variable for which you are aiming for. So what I mean to say is, let's say I give you a problem. I give you a machine learning problem or a case. Yeah. My case is that I am a telecom operator. I am Vodafone. Yeah. And I have subscribers with me. Subscribers are their subscribers. They have their attributes. That means they make calls, they send SMS, they use data, right? They are on my network for a few durations. They recharge, right? They recharge or they pay the bills in postpaid mode. Yeah. So they recharge, uh, they pay the bills. They they will recharge in different modes, online or physical modes. Their transactions will be different. Some people will be using, let's say, a person can be recharging with a very high duration in the a very high amount in the very first transaction. Some people might break it over the entire month, right? So you do have your transaction amounts also. So based on these parameters, all the subscribers would have a different trend with them, would show a different interaction with the brand, with Vodafone, right? So you have subscriber 1, 2, 3, 4, 5. And now as a Vodafone, you want to predict that which subscribers are going to churn out of my system. That means they are going to stop using my service in the next 90 days. Let's say you want to predict that. And what would you do with that? If you know that person ABC is going to churn out, why not entice the person, why not entice the subscriber with some lucrative offers that if you recharge with X amount, you get 20% extra. So all those things can happen where you want to arrest that churn, where you do not want your consumers, your subscribers to churn out of the system. That is a prediction. Now, in that case, the variable which you want to predict is called, let's say I'm naming it churn, no churn, right? This variable which I'm highlighting in yellow, it is called the target variable. Target variable, right? All the other variables which you are using to make that prediction, they are called independent variables, right? They are called independent variables. So this variable can also be called as dependent variable, right? So these variables, these are the interactions, are the attributes of the subscriber, of the customer. And based on these attributes, you are going to predict that whether the customer is going to move out or not. A very simple reason can be, let's if I tell you that for subscriber one, the data usage in January 2020 was 100 GBs, then it moved to 90 GBs, then it moved to 80 GBs, then it moved to 70 GBs, then 60 GBs, and so on and so forth, right? So it's a good indicator in itself that the customer is going to move out of the system, is going to churn, is going to leave the operator very soon. Now just imagine that this is one variable. If I tell you that we have 120 such variables, then you need the machine learning algorithm. Okay. Now, simplistically put, if you have a target variable, it is a supervised learning problem. If you have a target variable. If you do not have a target variable, it is unsupervised learning. So in the case of unsupervised learning algorithms, what you would have the same attributes, but now you will ask the algorithm that statistical algorithm based on mathematics, tell me what trends, what patterns do you see over here? And algorithm will try to find out those trends itself, those patterns itself. So simplistically put again, just to give you an example, let's say algorithm might classify, might cluster all the customers who use more than 100 GBs of data and recharge with, let's say, $100 or let's say $500 in a month, right? So algorithm might classify, and that can be one bucket. Second bucket can be, let's say, 50 gigs to 100 GBs and recharge with, let's say, again $400. So algorithm might cluster these customers in the same buckets. Okay, because I do not have a target variable. I do not have a variable I can vouch for. So the algorithm, I'm asking the algorithm, please find the trends yourself. That is unsupervised learning, where you do not have the target variable. Semi-supervised learning, it falls in between the cracks, where you do have some historical data, some data to train the algorithm for supervised learning or unsupervised learning, and from there you move to the next version. So let's say what I mean by that is you do have some starting data set, right? Let's say a unsupervised learning based problem, you have that, right? But you do not have a very extensive data set. So you build your uh, your unsupervised learning problem on a smaller data set, and then you migrate, you graduate, you extend it to a very high level problem that can be a semi supervised learning problem, right? Where you have dearth of data, but you want to use a blend of both, a best of both. Yeah. Now when it comes to the algorithms for them, right? So we will study all of those algorithms. We will study all of those algorithms over the entire webinar series: regression, decision trees, random forest, all of them, right? We'll study them. Today we'll study market basket analysis and recommendation engine. Yeah. A small tip for your interviews, a small suggestions for your interviews, that if you're going for data science machine learning interviews, uh, try to practice, try to cover or create at least one algorithm from each bucket, right? From supervised, unsupervised, and semi-supervised, right? Uh, Again, a small insight: the industry mostly mostly has supervised learning problem. The reason for that is, supervised learning problems, um, they are used for prediction, right? So most of the algorithms, or a big share, is for supervised learning as compared to unsupervised learning algorithm. But that being said, unsupervised learning algorithms are very powerful, very powerful. Yeah. Okay. So before your interviews, please try to create one project out of the three buckets. Yeah. Some skills that you can have, programming, analysis, machine learning concepts, and SQL. They are on the technical side. Then comes the practical side of things, right? All these soft skills are good to have in terms of your communication, in terms of your accountability, and they are no different from any other job, any other field. Yeah, but they are much more important over here, they are much more relevant over here. Yeah. One question that people generally ask me is that how can I start my machine learning journey if I do not have any experience with that. I'm a fresher, or I do have, let's say, experience in technologies like .NET or Java or into business intelligence. Then how can I start my machine learning journey? So it starts with creation of your profile. You know that if you can create a very strong digital profile in terms of Kaggle, in terms of your LinkedIn sessions, webinars, um, your representations over blogs like in Medium or Data Science Central, right? So all those things, they will add on to your profile, and you have to network. You have to network really hard, right? With the data science community, with the recruiters, and then you can slowly create your profile and move to the data science and machine learning side of things. It will take time. You have to be patient. It won't happen in a day. It won't happen in a week. It won't happen in a month or 2 months. It will take solid 6 months, at least 6 months of dedicated time. It will take to build your profile on that part. Yeah. Okay. So that being said, let me move to the next bit. The two technical topics for today: market basket analysis, and after that we'll discuss the recommendation models. Now, what is the meaning of market basket analysis? Um, Let me give you a small example. So let's say you want to make a cake, yeah, and for cake you need, let's say wheat flour, oil, sugar, cocoa powder. All these ingredients will be required for that. One way is that you enter the retail store, and so you enter your Tesco, your Walmart, your Hypercities of the world, your Star Bazaars of the world, and over there you go to different aisles, different sections, and you pick stuff. Yeah, that is one way. The second way, what retailers do is they try to keep the ingredients of these things, which are used together, which are bought together, closer to each other, right? Or it allows them to create a basket. Now, a very simplistic example can be milk and bread. So you would think that, okay, milk and bread will be bought together, or potatoes and tomatoes will be bought together in the same basket, right? That is the meaning of market basket analysis. That um, if I have an invoice, from the invoice, can I find out certain rules which allow me to generate rules, okay, rules which define the shopping patterns of people, the shopping patterns of my consumers, okay. Consumers, do they depict the pattern which are not visible to naked eye? Like potatoes and tomatoes is not an intelligent rule. Anybody can guess that. Milk and bread and eggs is not an intelligent rule. Anybody can guess that. Right? But if I tell you that if customers who buy this brand of sunflower oil, their chances to buy this particular brand of cookies is very high, right? So in that case, you would create something, some offers, some basket, some promotion around that insight. Okay. The second thing that you can observe yourself once you enter the supermarkets next time, yeah, or even not even the supermarkets, the apparel stores and all of that. On that, on the floor of supermarket, right? You have entire pattern of things, right? It is not random. Please don't think that in one aisle if you have uh, soft drinks, in second aisle if you have the munchies, the chips and biscuits of the world, it is random. No, it is by design. It is the data has been studied, is being studied for that in aisle number one, should I put my frozens, or should I put my frozen in oil number 2? Yeah, because that pattern is studied, that what is the movement of customer from aisle 1 to aisle 2 to aisle 2 to aisle 3 and so on and so forth, right? What is the trend that the customers depict from their invoices, right? That is the meaning of, that is the usage of market basket analysis. Now, how do you do that? How do you achieve that? Yeah? So to achieve that, there are three primary KPIs which are used, and this, this is called market basket analysis, sometimes referred to as association rule. Association, TION, association rule, right? A very famous algorithm is a priori for that. A priori algorithm is most of the time used. You would see that. Yeah. Now, how do we define that? How do you do that? So what will happen is, and just a word of caution: data preparation for market basket analysis is the most toughest part. But once you prepare the data, then it is easy to create the rules. When I say the rules, what I'm talking about, I'm using rules, but what is the meaning of rules? Rules mean that if I tell you that let's say oil, cookies, yeah, and leading to, let's say give me one example, let's say conflicts, right? If I tell you this, a very simple rule, yeah, and this rule, as compared to, let's say potatoes leading to tomatoes, right? So what I'm saying is, in the first rule is that if a customer buy oil and cookies, it is a very high probability that they would buy cornflakes in the same transaction, right? As compared to second rule, that if the customer has bought potatoes, the customer will buy tomatoes. So obviously the first rule is much more relevant. That is what is meant by a rule. Now you will get many rules, thousands of rules you can get, right? Generally, the first rule is actually most of the time I have found this rule. I mean, the data set was not up to the mark, was not clean. That's why the first rule was like this. So get rid of that. Yeah. The second rule you would get uh, is packing material, right? Because remember the polythenes, the packaging, all of that material that we buy once we buy our groceries. That comes to the second rule. After that comes the most relevant rules, right? You assess those rules on these three parameters: support, confidence, and lift. What is the meaning of support and confidence? So let's say out of all the invoices, if your your combination of rules, let's say this is milk and bread, they are present in 1/5 of the transactions. So your support will be 1/5. That means 20%, right? Confidence is that how often that rule is true. That means how often X is leading to Y. That means how in in what percentage of transactions Y was present when X was present. I'll repeat. In what percentage of transactions Y was present if X was present. That is a confidence. That means you're telling me, what are you assessing? You're assessing that if X was present, then in 80% of the transactions, Y was also present. That is the confidence bit, right? Lift. Lift simply means that uh, if this rule is true, right? Or if this rule is there, what is the dependency of these events on each other? That is the meaning of lift. So if the lift is 1, that means X and Y are independent of each other. Okay, if the lift is 1. If the lift is more than 1, then there is some dependency on the two two attributes or the two items. So X to Y, if the lift is 5, that means there is a dependency of the two items on each other. Yeah, that is the meaning of lift. So support, confidence, lift together, they contribute to your success of the rule. Okay. For market basket analysis, I'm not discussing the Python code in today's session. I've uploaded to the GitHub. I'm discussing the recommendation system Python code, because I want to spend a good 15 minutes on that. Yeah. So recommendation systems are used for making the next set of recommendations or next set of products, like Amazon does to us, right? Like Netflix does to us, that based on your historical trends of movies, these movies or these items are more suitable for you. Are you interested in them? That is the meaning of recommendation systems, where you want to suggest next set of products and services for your customers. Yeah? What types of recommendations models you can have? Very simplistic. Let's why can't we simply suggest the most popular item? So the item which is present in most of the transactions, suggest that. So let's say in a grocery store, if you think that tomatoes are present in, or bread is one of the very fast moving item, so it will be present in most of the transactions. Let's suggest bread. That is the popularity based recommendation model. But that recommendation model, this popularity based recommendation model, it does not make sense to each and every one of us, right? Because it is not customized. Like for example, if you go to an apparel store, right, over there t-shirts might be the most popular item. So in that case you would recommend t-shirts to everyone. But if you want to take a more scientific approach, you have to take help of collaborative filtering models and matrix factorization methods. Okay. What is the meaning of collaborative filtering models? Collaborative filtering models, they again use historical data. There are two types of collaborative models: user based and item based. What is the meaning of them? What we uncover by the data is that consumers who have bought similar items in the past, what next was their purchase, right? And customers we have similar profile, we will recommend the same products to them. I'll repeat. If you have a A, consumer A has bought ABC, consumer B has bought ABCDE, right? So since both of them have bought ABC in common, you might recommend D and E to consumer A because they have shown similar preferences towards products, similar preferences towards services. So let's say movies. So if I know that the first consumer is watching uh, action thrillers and science fictions, and based on that, the next set of purchases were towards war movies. And in today's case study, we are going to build that uh, that code itself, right? So using that understanding, I can build the recommendation model, okay, where I check the similarities between the users. The same concept if I extend to the item base, where instead of approaching from the customer side of things, I approach from the item side of things, right? The customers know which items are more lucrative. Okay, so over there also we measure the similarity. Okay, the second types of one sec. I talked about similarity, but how will you measure the similarity, right? Similarity measures and in a mathematical form. How will you do that, right? So that can be done using the similarity measurements, the attributes that we have, the cosine similarity, the Pearson correlation coefficients, and the Euclidean distance. What I won't go into the mathematical complexity, but what they mean is that if I have 2 points, right, in a vector space diagram, I have point 1 and point 2 and point 3. If I want to measure the similarity between them, if I measure the distance, simple distance between them, that is Euclidean distance, right? If I measure the angle between them, right, that is the and take a cosine of that, that is my cosine similarity. Okay, that is my cosine similarity. Okay, and Pearson correlation is a correlation coefficient between them, right? So using these similarity measurements, these KPIs, you can measure the similarity between data points. Okay, so what it means is that if you have, let's say, you know, and for collaborative filtering, most of the time you would find that we use cosine similarity. So if you have user one and if you have user two over here, right, the Euclidean distance will be quite high, but the cosine similarity, Euclidean distance will be quite high between them. That means they are dissimilar, right? If the distance is higher, that means they are dissimilar. But the cosine of the angle will make them quite similar. So that is how they they change the dynamics of your model, the dynamics of your solution, right? The second type of recommendation models are your matrix factorization method, right? So matrix factorization method, what again, they are based on the uh, uh, they are more advanced than your collaborative filtering models. Let's put it this way, right? And I will show you now that how and why they are more slightly better than collaborative filtering. Once I show you the Python code. Okay. All of this code is uploaded to my GitHub profile. Please feel free to use that. Okay. Now first the data set for you. This is the data set that we have, right? The data set is that I have user IDs, I have movie IDs, I have the ratings, right? And for each user ID, I might have quite a few movies which the user has graded, has ranked, has given their ratings, right? So based on those ratings, for a particular user, for a particular movie, I want to recommend the next set of movies for the user. This is my business problem, a very practical business problem, right? For any business, it can be relevant. So how do you do that? Yeah. So I import my libraries over here. My NumPy, Pandas, and my Seaborn library. Seaborn library is more for the visualization purposes. Similarly, Matplotlib. You read your data set, your ratings data set that we have over here, and then I am exploring. I'm simply doing one exploratory analysis on my ratings data set. So number of users are 671, and I have 9,066 movies in total. Unique movies are 9066, and that we did a small group by on them. Okay, uh, let's there are these movies. They are ranked by most of the users. Few users, they have ranked as close to 2,391 movies. Yeah. So again, you know, uh, a bit of exploratory analysis on the data. Over here, I have my interactions by the users, or representation of the same data in a histogram, right? So I have my interactions, my ratings, and we have group by on the user IDs, and where the count is the movie ID. That is my interaction counts. Yeah. If I simply create a recommendation model based on the number of times it has been rated. So by that I mean that I do have few movies which might be rated quite a few number of times. That means they are very popular movies, right? If I simply take those movies, that will be my popularity based recommendation model, right? Again, very easy for me to put very easy for me to pick, right? So if you want to build a recommendation model, let's say in 15 minutes, you uh, simply rank the movies in decreasing order of popularity and pick the top 10, recommend them. That's it. Yeah. So that is a popularity based one, right? So I can slightly spin that popularity movies, that idea of popularity based, where I work on the average ratings, right? And I can pick my top movies over there. Okay. So I recommend the top 5 movies based on popularity, and which have been rated at least 50 times or 100 times, whatever is up to me. I can simply recommend those movies to any user. Now it is to any user. If I want to build a collaborative filtering based model, right? So I can build a similarity based model over there. So again, I create a good matrix, a heavy matrix over there, because I have to create my data set where for each user I have the corresponding rating. Now, obviously, you can see over here the data set is quite sparse. There are lots of not a number over here, because not each and every user has ranked each and every movie, right? But that is the way the data set is, and we cannot we cannot solve it, because that's how it works, right? And this is the cosine similarity concept I was discussing about, the cosine of the angle between them. Look here, please pay attention now. Cosine similarity, right? From scikit-learn library, I simply import my cosine similarity, and I simply, I'm not explaining the code in complete detail. You can take the code from GitHub. But the point I want to stress is, this is your cosine similarity uh, code, where you are you are calculating the cosine similarity between data points. So I repeat now myself that data preparation is a very big step, right? Model creation is a smaller step. And you would see that in the future sessions also, once we build more complex solutions, that a model creation, or like over in this case cosine similarity finding, it was easy, because it was only a single line of statement, right? So what you do over there, we have done one small step in between, that we have replaced all the NAs with 0, right? And I have my interactions, my similarities between the users, and based on that, right, I can recommend to any user. So what is going to happen? What is going to happen is, let's say I have a user ID 123, right? You can see, a function has been created for that. I have a user ID 667, and I want to recommend some movies to this user. So what do? I simply find the similar top 10 similar users to this user ID 667, and based on that, right, I can recommend movies. Okay, so if I want to have six recommend 5 movies, so these are the top 5 movies which I can recommend. How again it is calculated? I found the users which have the most similar profile to this particular interested customer, and that's it. I found their movies and recommended to this particular user. Yeah. Then we have the matrix factorization method, right? Again, in the matrix factorization method, we can use my the singular value decomposition method for that, right? And for that, we have to convert it into this particular format first, and from there, you know, I can create my matrices, and I can I can train the model on that. Now I'll spend a minute on that, right? While if you want to create your model, right? Generally, if you have, let's say, a data set, you would divide the data set into train and test. What it means, that train yourself, develop your understanding on 80% of the data, historical data, and then I test it on the leftover 20%. That is my understanding, right or wrong. So again, I repeat, if you have a data set, it can be 80-20, sometimes it can be 70-30 also, right? If I take my data set, I divide into 2 parts. One part is used for training the model, one part is used for testing the model, right? So 70% of the data can be used for training the model, 30% can be used for testing that how good the model has been trained or not. Okay, we'll explore that in much more detail in the next 2 sessions of supervised learning, but today I'm just giving you a flavor of that. Okay, so again, you can use the same or the similar concept for your matrix factorization method, where you use singular value decomposition. Okay, so I know we are short of time, and it's but if you want to interact with the code, then this entire code has been uploaded to to GitHub, right? Use that. Use that for all your understandings, right? And please feel free to reach out to me in the next sessions if you have any questions.